How does wind create all the ocean currents? Ocean currents are mostly not created by wind. While wind can play a role, often minor, in shaping surface ocean currents, it is not the main or only factor. Furthermore, wind plays virtually no role at all when it comes to deep ocean currents. The main drivers of ocean currents are as follows. 1. The Coriolis force. The rotation of the Earth causes two main inertial forces. The centrifugal force pointing straight up, which is mostly swamped out by gravity, and the Coriolis force which points perpendicular to an object's motion. The perpendicular nature of the Coriolis force causes objects in motion to travel in great circles on the surface of the Earth. Systems in the northern hemisphere circle clockwise while systems in the southern hemisphere circle counterclockwise. The Coriolis force is very weak, so it has little effect on which way the water spirals in a sink as it drains. But when a lot of water is involved, such as in the ocean, the Coriolis force plays a large role. Because of the Coriolis force, the major ocean currents in the northern hemisphere tend to spiral clockwise and they tend to spiral counterclockwise in the southern hemisphere. These current patterns can be seen in the image below. The Coriolis force is an inertial force that arises from the Earth being in a rotating reference frame. The Coriolis force is not imaginary or fictional, but is simply inertial, meaning that it is very real in the rotating reference frame, but is not fundamental as it arises from the motion of the frame itself. 2. Density differences. Fluctuations in both temperature and salt content lead different regions of ocean water to have different densities. Higher temperatures, such as near the equators, cause a given mass of water to expand and therefore drop in density. Also, lower salt content causes a given mass of water to be lower in density. Gravity causes the more dense water to fall, pushing away the less dense water, which shoots sideways and rises. Giant convection loops of ocean currents form as the lighter, hotter, less salty regions of water rise and flow to replace the heavier, colder, more salty regions of water. The effect of density-driven currents is fundamentally a result of the interplay heating from the Sun, Earth's gravity, and salinity differences. 3. Tides. Differences in the gravitational field of the Moon from one location to the next causes tidal forces. Differences in the gravitational field of the Sun also causes tidal forces. Tidal forces push water towards the axis connecting the Earth and Moon, and the axis connecting the Earth and Sun. The water moves in ocean currents in response to these tidal pushes, causing the well-known daily cycle of high tide and low tide. 4. Shoreline obstruction. Although ocean currents are not directly generated by the shoreline, they are certainly shaped by the shoreline. As the water in an ocean current moves forward under the push of the forces listed above, it inevitably runs up against the solid mass of land and is deflected along the shoreline. The above-water shoreline, as well as the shape of the ground under the water's surface, the depth contours, both affect the direction of ocean currents. For more video like this, visit and subscribe our channel.